outside of the square root, in addition to this x that's on the inside of the square root. So, for this, we're going to have to solve this, but it's going to be a little tougher because we can't just square both sides quite as easily. So, any ideas? What do you guys think we could try on this? Okay, let's move this 3 over here so that that square root is by itself. So we got 3x, square root of 3x plus 1 equals x minus 3. What would you guys do next? Alright, so we're going to square both sides. Here's the big deal with this, though. When we square the left side, it is just going to get rid of that square root. On the right side, I am squaring x minus 3, which is not x squared minus 9 or plus 9. It means that I'm taking x minus 3 and I'm multiplying it by itself like this, x minus 3 times x minus 3. And I hope, as we've been working, that you're starting to square double square in your head so that you're not having to write everything out. If you need to, you can write it out. It's x squared minus 3x minus 3x plus 9. But it is better if at this point you can go straight to x squared minus 6x plus 9. Because these problems are going to have, especially the next ones, are going to have a lot of steps. And anything you can shortcut out that's going to give you fewer steps to write down is going to be helpful. So once I get to this point, what should I do? All to one side. When I have a quadratic, everything needs to go to one side. So I'll get 0 equals x squared minus 9x plus 8. And then I am going to factor. This one would be a minus 8 minus 1. So x would equal 8 and x would equal 1. So I told you guys on those notes that you guys did on Friday that you need to watch out for extraneous solutions, didn't I? I think. Yeah. But on that worksheet that you did, I don't even know that you had any. If you plug them back in, they all worked. On the simpler problems, it does not happen as often. But with these problems, it happens very often that we have extraneous solutions. So you can use your calculator if you want to check. 3 plus the square root, or you can do it in your head, or you can write it down. So 3 times 8 plus 1 is going to give you 8, which is what it's supposed to equal, because it's supposed to equal 8. So that one is an answer. It works. Then you also want to check the 1. So 3 plus the square root of 3 times 1 plus 1 is also supposed to give us 1, but it is giving us 5, which is not 1, right? So 1 is an extraneous solution here. Right, it's supposed to equal whatever x you're plugging in. Because if we wrote this down, we'd be doing 3 plus the square root of 3 times 8 plus 1 equals, we'd replace this x right here with an 8 also to see what we would have. So 1 does not work, 8 is our only answer. Whenever we were doing the excluded values with the fractions, occasionally we had times when the excluded value showed up as answers, right? In fact, on number 5 or something like that, it happened to you, and several of you lost a point or two, a couple points because you did not mark out that excluded problem, right? It happens more with square roots. In fact, whenever you get 2 answers, I would say more often than not, at least one of them is extraneous. So you're going to see a lot of answers being thrown out. It is really important that you check them here for these. So you got to plug them back in. It's not that you've done anything wrong solving. It all comes from the fact that when you square a negative, it becomes positive. So that causes there to be extraneous solutions sometimes. Okay, questions? All right, let's try this one. All right, if you see a problem like this, it should take you about half a page to solve this. So let me show you what people do wrong. I'm trying to warn you so that you don't do this. A lot of people do this. They square this side, they square this side, they get x plus 10 equals, maybe they say 25 minus 3x minus, or 3 minus x there. Maybe they just get rid of those square roots on the other side. That does not happen. Okay? If you have a problem like this with those two square roots separate, you're not going to get rid of the square root on the first square. So, I mean, like, from this point, this would be a super easy problem. So if you see a problem like this and you end up solving it in just a few steps, you've done something wrong. Okay? Now, if it looks like the ones you had last night where there's only one square root, it may only take a few steps. But these are going to take a while to solve because I can't get rid of these square roots just by squaring one. So if I square this side and square the other side, it does get rid of the square root on the left-hand side. I'm just going to have x plus 10. Because all I have on that side is a square root. It is going to go away when I square it. But on that right-hand side, I'm doing 5 minus the square root of 3 minus x times 5 minus the square root of 3 minus x. Alright, so I'm going to write it out over here, or I'll show you in a second the shortcut you can use, or it's still the square double square shortcut. So if I multiply here, I'd get 25. If I multiply here, I get 5 times square root of 3 minus x. So we just have to write it like that. 5 square root of 3 minus x. Then for the inside terms, I'd get another 5 square root of 3 minus x. And then for the last ones, what's going to happen when I got to multiply square root by that same square root? The square roots cancel each other out, right? Because it's like having square root of 3 times square root of 3, right? It's just 3. So this is going to be plus 3 minus x here. And then these two terms right here in the middle both have a square root of 3 minus x. So I could put those together. So I'm going to end up with 25 minus 10 square root of 3 minus x plus 3 minus x. So if you need to, over to the side, write that out and multiply those together. But I also just use a square, double square here whenever I'm doing this. So it's the same as we've been doing with the more simple ones. 5 squared is 25. If I multiply these two together, it would give me 5 or negative 5 square root of 3 minus x if I multiplied my two terms together. And then if I doubled that, if I multiplied that by 2, it would give me negative 10 square root of 3 minus x. So there's your double in the middle. And then when you square the last, you're just going to get rid of that square root. So either way that you want to think about that is fine. If you're uncomfortable doing the square double square because it just seems too confusing to think about with your square roots, it's fine to write it out on this. Oh my, what in the world are we going to do now? This looks worse than it did to begin with, just about. Okay, what should we move to the left? Alright, let's take out 25 over here. And 3. Let's subtract that here. And I'm going to add this x right here. So I got 2x. It's going to be negative 15 minus 3 will give me negative 18 equals negative 10 square root of 3 minus x. Okay, that made it look a little better. All right, ideas. What do you think, Matthew? Okay, we got to get rid of that square root. Now, I do have this 10 right here. I could divide by 10, but as Matthew said, it doesn't go into 2 and 18. So if I do divide by 10, I'm going to have fractions. I don't want to have fractions, right, because that's going to be difficult to deal with it. So you could do it that way, and if it will go evenly, do divide. But it won't go evenly here. So, I think it would probably be best just to go ahead and square. So when you square over here on the left side, that is not, just 4x squared plus whatever 18 squared is. We could square, double square here. So we got 4x squared. That's going to be 36, and we got to double it, so we're going to get minus 72x plus 18 squared is 324. Now, here's what you got to be careful with on this right-hand side. You got to square this is not negative 10 plus square root of 3 minus x. We don't have to distribute here. But we do have to square the 10, so that's going to be 100. And then we're going to square the square root, and that's going to be 3 minus x, but leave it in the parentheses because we're going to have to distribute our 100. Yes?
Would it not be minus 36x plus 18 times 2?
You've got to multiply these two terms together first, which gives you negative 36. But then you've got to double it, which is going to give you that negative 72. All right, square roots are finally gone at this point. So we can distribute this 100. So 4x squared minus 72x plus 324 is going to equal 300 minus 100x.
Why didn't we just multiply the negative 10x by itself and square root by itself instead of having minus the square?
So the difference is this, like if I had 2 times the square root of 5, and I needed to square that, that is 2 square root of 5 times 2 square root of 5, and there's no plus or minus signs there. So we just multiply the things on the outside, which would give us 4, and multiply the square root of 5 times square root of 5, which would give us 5 right there. So we're just squaring each one of them, really. 4, and then square that, we'll get rid of the square root. If I had 2 plus the square root of 5 squared, then I would have to distribute. So that's the difference there. Since these are just multiplied, you can just square each one. But you cannot do that when there's plus or minus signs. That's a good question. Okay, let's move everything to one side. Let's add 100x here. And subtract 300 here. So we got 4x squared plus 28x plus 24 equals 0. And what do we need to do now? I divide by 4 because 4 will go into all of these, and that will make it easier to factor. So we divide everything by 4, so we got x squared plus 7x plus 6 equals 0. Finally, we're down to something that is pretty easy to factor, so we should get an x plus 6 and an x plus 1. So our answers end up being negative 6 and negative 1. But with these types of problems, you always have to check for extraneous solutions. So it's fine with me if you use your calculator on this. So first thing we're doing is we're plugging in negative 6. So we got the square root of negative 6 plus 10. Needs to be equal to 5 minus the square root of 3 minus negative 6. Actually, this is pretty easy to do by hand. I think I'll do it by hand. So that's going to be square root of 4 equal to 5 minus square root of 9. So 2 equals 5 minus 3, which is 2. So that one works. Negative 6 is an answer. We also are going to check negative 1. So we'd have negative 1 plus 10 equals 5 minus the square root of 3 minus negative 1. So this is going to be square root of 9 equals 5 minus square root of 4. And so 3 equals 5 minus 2. I'm going all the way back to the original problem. So go all the way back to the very beginning when you're plugging these in. Technically you could plug it in like later, but you may have made a mistake up to that point, so you don't want to do that in case you made a mistake before that. So this one also works. So this one actually has 2 answers. And some of them will have 2 answers. But you always need to check because it's pretty common for one of them not to work. Have questions? All right, let's do another one. So we got the square root of a plus 21 minus 1. That shouldn't have 2 equal signs there. Don't know why it does. Pretend like there's not 2 equal signs there. But it equals square root of a plus 12. So when we do this, we're going to square both sides, which is going to be easy on the right-hand side, but not so much on the left. So I'm going to write it out over here for those of you that need me to write this out. Because this is the hardest part for most students, is the squaring this expression. So when you multiply square root by itself, you just get a plus 21 here. And then you'll get minus 1 times the square root of a plus 21. In the inside, you'll get another minus 1 times the square root of a plus 21. And then negative 1 times negative 1 is positive 1. Or we could have just squared, double square right away. We'll get a plus 21 minus 2 square root of a plus 21 plus 1, which is the same thing we get if we just combine those 2 middle terms there. On the right-hand side, the square roots will just go away. Yes. The side that only has a square root. So this side over here, it was just a square root, and we were squaring it, so those are going to cancel. But over here, it can't cancel because you've got this minus 1 that's not underneath the square root. If both sides, everything was on a square root, you could just square both sides and they'd go away, like some of those last ones that you had on your homework. But if you got something not under the square root, then you got to write it out for that. Okay? All right, so we need to move everything away from the square root because we want to square this again, so we can subtract that 1, subtract that 21, and subtract that a. Well, this is kind of nice right here because whenever you do this, the a is going to cancel. So we are going to have negative 10, I believe. So that's going to make this problem a little bit easier. Questions? Alright, now in this case, we can just divide both sides by negative 2, and that's what I would suggest doing instead of squaring it right away. So we got square root of a plus 21 equals 5. Now we're down to something like we were seeing last night. So square both sides. A plus 21 equals 25. Subtract your 21. So a equals 4. And you always need to plug it back in to make sure that it works. So square root of 4 plus 21 minus 1 is supposed to equal square root of 4 plus 12. So this is square root of 25 minus 1, which is 5 minus 1. So we get 4 on this side. And that equals square root of 16, which is 4. So this does work. There are some occasions where you plug this number back in and it does not work and it's your only answer. So if that's the case, you'll get no solution for that problem. Just be careful, like if you do the homework and you're getting no solution for every problem, like you plug all your answers in and they're all extraneous solutions, then you're probably doing something wrong because you've solved it incorrectly. So those aren't going to be the answers anyway because you did something wrong. So you'll get extraneous solutions a lot, but you shouldn't be getting no solution except for occasionally. Alright, questions? Alright, let's try another one. Okay, so for this problem, I'm going to do it wrong here for a second, so don't do what I'm about to do. This is what most students do wrong. They do 2x plus 1 plus 2x plus 6 equals 25. It would be nice if we could do it that way, but we cannot, because if you do it this way, you've got to do square root of 2x plus 1 plus square root of 2x plus 6 times the square root of 2x plus 1 plus square root of 2x plus 6. And then you have got to distribute, which is going to be a nightmare because that first part is going to be 2x plus 1, but the second part is going to be like square root of 2x plus 1 times 2x plus 6 underneath the square root. This is going to be bad. It's going to be really confusing to have to try to do it this way. So you can't square it and just get rid of the square roots. That is wrong. I also don't want to do it the way I'm doing it over here because that just looks like it's very difficult to do. You could do it that way, but I don't want to do it that way. So, any ideas on something we could do first that might make this easier? What do you think, Major?
It doesn't matter either one, so you could move one to the right side.
Let's do that. Let's move one of them to the right side. So I'm going to take this square root of 2x plus 6. But like Major said, it doesn't matter which one you move. You could move either one. So I'm going to change this to square root of 2x plus 1 equals 5 minus the square root of 2x plus 6. This just makes it a little bit better so that when you square that right-hand side, at least you don't have two square roots, right? So over here on the left-hand side, easy peasy, just gets rid of the square root. Over here on the right-hand side, we got 5 minus square root of 2x plus 6 times 5 minus the square root of 2x plus 6. And we got to distribute 5 times 5 is 25. We got 5 times the square root of 2x plus 6. We got another negative 5 times the square root of 2x plus 6. And then we've got plus 2x plus 6. Or we could have squared double squared from the beginning. 25 squared is 25. The double is going to be minus 10 square root of 2x plus 6. And then we'd have plus 2x plus 6. Oh no, I just realized something bad. I realized that last year I worked the book problems, and that's what I was going to give you for your homework. I thought these were looking too familiar. I may have to adjust what I was going to give you for your homework. You need at least a little practice with this stuff. Alright, so let's move everything to the left-hand side. So, except for the square root. So, subtract that 25. Subtract the 6. Subtract the 2x. Oh, this is convenient here. The 2x's cancel for this one, so that's good. So, we've got negative 30 equals negative 10 square root of 2x plus 6. So from here, let's see, Major, what would I do next?
What I did is I decided to
Good. Since it goes evenly, let's do that. That'll make our lives a lot easier. We just get 3 equals square root of 2x plus 6. Manuel, what would we do next? We can finally square this here. So we get 9 equals 2x plus 6. And now we're down to a simple two-step equation. So we subtract 6, we get 3 equals 2x. Divide by 2. So x equals 3 halves. I think actually, no, it's pretty easy. You do always have to check these. So, if we're checking this one, we're doing the square root of 2 times 3 halves plus 1 plus the square root of 2 times 3 halves plus 6. That's to equal 5. And you can do it in your calculator if you want, but the 2 is going to cancel right here with this 2, so it's square root of 3 plus 1, which is 4. And same thing, 2's cancel here, so it's square root of 3 plus 6, which is 9. So 2 plus 3 does equal 5, so we get 3 halves is our answer.
So the only time you check it, like to equal what it is if it equals x.
Correct, yes. So you're just plugging back into whatever you have at the beginning and seeing if both sides of that equation are equal to each other. So it just depends on, like in this case, you're wanting all this stuff over here to equal 5. But on the last one, we had to kind of like work on both sides. Okay, questions? All right, let's skip on and do this one. try this one if you want. Let's see. Now, on this one, is there any possible way to avoid having two square roots when you share it, or whenever you...
You can't, like, so you add the square root of k over, you can't combine that and make it 3 plus k, square root of 3 plus k.
You cannot, no. You cannot add square roots. So, like, if you do this, it's going to have to look like this. K plus 9, square root of k plus 9 equals square root of 3 plus the square root of k. If we were multiplying, we could put them together, but we're not, so we can't do that. But I still think this is going to be a little easier than if I have the k plus 9 minus square root of k there. What do you think? You cannot do that because it's plus. It would have to be like 9 times k for you to be able to do that. So you can't pull that out. So, sorry, I'm trying to upload this picture to the... so that I can change your homework since I've done all the homework problems. Alright, so it is going to be a little easier to square if we do this than if we had left it like it was. So I'm going to do that. So let's square this. So we got k plus 9, and I'm definitely... I could square double square, but that seems like it's going to get crazy, so I'm going to write it twice here. So I would have to do square root of 3 times square root of 3. That will give me the square root of 9, which is 3. Then I'll get square root of 3 times square root of k. I'm multiplying here. Both things are underneath the square root. So I can write it like this, square root of 3k. Since they're both under the square root, I can multiply them, but they got to stay under the square root. Same thing here. I'm going to get that same term again, which always happens, right? That's why we get a double there. And then on my last term, I got to do square root of k times square root of k. So that's just going to give me k. Now, these two terms right here can be put together. What am I going to get when I do square root of 3k plus square root of 3k? What do you think, Matthew? Perfect, because it's like they both have 1s in front of them. We're just combining them there. So k plus 9 equals 3 plus 2 square root of 3k plus k. And you could have gone straight to that with the square double square if you're okay with that. So now it's really not so bad anymore, no worse than it was for the other problems at least. So, in fact, we're going to subtract this 3, and we're going to subtract that k, which will get rid of the k on that left-hand side, so we get 6 equals 2 square root of 3k. I would even divide off that 2 because 6 is divisible by 2, so 3 equals square root of 3k. I'm going to square both sides, so 9 equals 3k, and divide by 3. So 3 equals k. And we need to plug this back in to make sure it works. So we got square root of 3 plus 9 minus square root of 3 is going to equal the square root of 3. Let's see if it works. I think I'm just going to use the calculator on that. Because you're going to have square root of... Actually, no. I'm going to do it this way. But you could use the calculator. That's going to be square root of 12 minus square root of 3. 12 breaks down into 2 root 3 minus root 3. That's like a 1 root 3, so that would be square root of 3 equals square root of 3. Or you can type it in the calculator and see if you get the same decimals there. Because that would just be square root of 12. So square root of 12 minus square root of 3. It's going to give you this decimal, and then you can just type in square root of 3 to make sure it's the same decimal, and it is. So, k plus 3 is our answer. Alright, questions? Okay, I was gonna give you an assignment that was from the textbook, but I'm just now realizing that those are the problems that I used for this. I don't know what I gave for the assignment last year. Maybe I used Delta Math or something. I don't know. So let me change your assignment real quick.